In the last video, we used parallel lines to talk about angle relationships. And in this lesson, we're taking that idea and flipping it on its head. Before we do that, a little bit of vocabulary that needs to be covered. The converse of an if-then statement is found by switching the P and Q. So what I mean by that is when we think of an if-then statement or a conditional statement, we think of if something, then something. So when I'm saying that we're swapping the P and Q, what is basically happening is that the order of the statement has been reversed. So in the previous lesson, we talked about how if lines are parallel, then these different angle relationships will exist. And so we're taking those concepts and flipping them around. So I have in this diagram a pair of lines that have been cut by a transversal T, and I have these statements. And these statements, the blanks within them, will become more apparent as we go through A, B, C, and D. So in part A, it says, use two of the given statements together to complete a statement about this diagram using the same side interior angles postulate. Well, the same side interior angles postulate says if lines are parallel, so if lines L and M are parallel, then angle 6 and angle something will be supplementary. Well, they're same side interior angles, so notice what angle in this diagram is a same side interior angle to angle 6. It's angle 3. So in part B, now it's asking us to write the converse of that statement, which means we're basically switching the statement around. By its converse, if angle 6 and angle 3 are supplementary, then lines L and M are parallel. And then repeat this concept to illustrate the alternate interior angles theorem and its converse. So by the theorem, the alternate interior angles theorem, it would say if lines L and M are parallel, then angle 4 would be congruent to what? Well, again, look at the diagram. What is an alternate interior angle to angle 4? That would be angle 6. So taking the converse of that, I would be saying if angle 4 is congruent to angle 6, then lines L and M are parallel. Finally, corresponding angles theorem says that if lines L and M are parallel, then an angle would be congruent to angle 7. So looking at the diagram, what angle is a corresponding angle to angle 7? That would be angle 3. Its converse would say if angle 3 is congruent to angle 7, then lines L and M are parallel. So reflecting on what we just did, how do I form the converse of a statement? You might say you switch the if and the then. What kind of angles are angles 4 and 6 in step C? Angles 4 and 6 were alternate interior angles. And so what does the converse mean? In generic terms, it means if alternate interior angles are congruent, then the lines that were cut by a transversal are parallel. And you see in Explain 1 that that's pretty much exactly what these converse postulates and converse theorems are saying, is that if two lines are cut by a transversal such that a pair of same-side interior angles are supplementary, or a pair of alternate interior angles are congruent, or a pair of corresponding angles are congruent, then I can use that to prove that the lines are parallel. So in example 1, I have a mosaic designer that is using these quadrilateral shaped tiles to make a design, and each tile is congruent to this one. So in this diagram I have these 4 tiles, and in the diagram beneath it, it doesn't show up very clearly on my page. Hopefully it shows up a little bit better on yours. There should be a line here such that it's clear what angle 1 is in this diagram. It's the 120. And what angle 2 is in this diagram. It's one of the 60s. And so what is the relationship between the two angles? They are supplementary. And since they are supplementary and they also happen to be same side interior angles, I can conclude that line 1 is parallel to line 2 because of the converse of the same side interior angles postulate. Here, angle 1, let me take this diagram and copy it over onto the next page. Okay, so angle 1 is this diagram, is this angle, 120. Angle 2 is also 120. And the relationship between the two angles, they are congruent. And they are congruent, and notice that they are also corresponding angles. So my conclusion, therefore, is line L1 is parallel to line L2 by the converse of the corresponding angles theorem. And I want to stress to you again, just like I did in the last video, please do not let yourself get hung up on, oh my gosh, which one is a theorem and which one is a postulate. That's not what's terribly important to us here. However, there's a big difference between the converse of the corresponding angles theorem and just the corresponding angles theorem. Okay, so the big difference is the corresponding angles theorem I use to conclude something about angles. The converse of the corresponding angles theorem I use to conclude something about lines. So be very careful about the difference. In this reflect question, asking us to think about what we just finished doing, it's asking, suppose that the designer had been working with this basic shape instead. Do you think that the conclusions in part A and B would have been different? Well, in part A, I would have been looking at these two angles, which are still supplementary, so that conclusion wouldn't have been any different. In part B, I would have been looking at this angle and then this angle again, so that conclusion wouldn't have been different. So no, because the relationships in parts A and B would be the same. in this your turn 4, it's asking us to explain why the lines are parallel. So we're using this same diagram here. This angle 1 is 120. This angle 2 is also 120. So they are parallel because of the converse of the alternate interior angle theorem. And notice this word here, pull out your compass and straight edge. In this lesson, we're coming back to doing a few constructions, and we'll see some more later in this module as well. We're using what we just saw here in order to construct parallel lines. So we're using the fact that congruent corresponding angles will yield parallel lines. And so you see in example 2, part A, that they are talking you through the whole process, and then in part B, I will show you the process. Okay, so in part A, I have a line, I have a point, and my first step is to make 2 points on this line, and it's asking us to label them Q and R. And then it asks us to draw a line through P and Q. So in essence, what we're doing in this step is creating an angle, and it's a random angle. Where the process stops being random is when you construct an angle congruent to this angle. There's that construction again, it doesn't go away. An angle congruent to this given angle through this point, and that will give us the parallel lines. Okay, so follow along as I do it on the screen. Okay, so it says, draw a line S and a point G not on S. So there's my point G. This is my line S. And it says, choose 2 points on S and label them E and F. Okay, so I'm going to make this my point E and make this my point F. And then I draw line GE. Now notice that I didn't stop it at G and I didn't stop it at E. You definitely want to extend past that point that you're going to eventually construct the parallel line through. Okay, so make sure that you're giving yourself some space up here. It says, then use a compass to copy angle GEF at point G. Okay, so let's remember how to do that. I'm going to make a random compass setting. Now, I'm going to make it go through F just so that that point F kind of has a purpose. Okay, so I make this arc. Now, notice that my arc is not passing through G. That's okay. Remember to make sure to duplicate that arc not from here, but from G. Okay, so this compass setting, I recreate from G because G is going to be the vertex of my new angle. You want to make sure that you're making it a big enough arc that you can eventually copy this angle from G through it. Okay, so make sure that you're making a good sweepy arc. You have an idea of where that parallel line is going to be. Make sure that your arc goes past that. Okay, the next step, remember, is to change your compass setting to this distance. taking this compass setting, whoops, let me make sure I didn't change my compass setting by accident. There's my compass setting. Notice where I'm putting the point of my compass. And then I duplicate that arc. And notice that those arcs intersect. And now from G to that intersection of arcs, that is my parallel line. It's asking us to reflect back on that construction that we just did. How do I know that the construction will produce a line passing through the given point that is parallel to the given line? Well, back here, remember we called this angle GEF. I could call this maybe point H and this J. We constructed angle JGH to be a congruent corresponding angle to angle GEF. Therefore, by the converse of the corresponding angles theorem, line GH will be parallel to line EF. And now I also kind of want to point something out. My construction might not be perfect. You may have noticed that the point of my compass was drifting a little bit. But when I test you on this, what I'm looking for is not how perfectly constructed that parallel line is, but did you follow the appropriate steps? And if you don't have the arcs there, then you did not. In the next explain, we're talking about using those angle pair relationships to verify that lines are parallel, and you'll notice that there's some algebra involved here. So in the first example, part A, they talk us through it. They tell us that angle 3 is congruent to angle 5. So I look at the diagram, I notice that angles 3 and 5 are alternate interior angles. So, are the lines parallel? Yes, they're parallel because the converse of alternate interior angles theorem says if I have a pair of alternate interior angles that are congruent, then I have a pair of parallel lines. Part B, I'm given this algebraic expression for angle 4, I'm given this algebraic expression for angle 8, and then I'm told the value of x. So this is a little bit more involved. Step 1, first I want to identify the relationship between the two angles. So I'm going to take the 15 and plug it in. So I find that the measure of angle 4 is 35. And I find that the measure of angle 4 and angle 8 are congruent corresponding angles. Are the lines parallel? Yes. By the converse of the corresponding angles theorem. In this your turn example, we're asked again to identify the type of angle pair described and how do I know that the lines are parallel. So here I'm told that angles 3 and 6 are supplementary. Notice that they are same side interior angles. So I know that the lines are parallel. Angle 3 and angle 6 are same side interior angles. The lines are parallel by the converse of the same side interior postulate. Pause your video and work through the Your Turn Below, number 9.